Hi everyone, my name is Ava Mendez. My major is liberal studies.
Hi, my name is Madeline, and my major is also liberal studies.
Hi, my name is Pania. My major is also liberal studies.
My name is Leticia Martinez, and my major is also liberal studies.
And today, for our presentation, we got percent problems with bar models. And this grade level is from 6th or 7th grade. We will show how students build understanding of percent problems using visuals before formulas. Now, the goal for students is to be able to find a percent of a number, find the whole, and also find the percent. For the standard, we use proportional relationships to solve multi-step percent problems. And then why bar models? Well, the key idea is for bar models, they equal visual representation of parts and wholes. It allows students to decide what operation to use. And then we have our example right here. For bar models, they help show parts and whole visually. Right here, we have 70 and 30 make 100. This helps students choose the right operation and understand the relationships because they often understand relationships more than formulas.
The lesson overview is on day one, we will focus entirely on hands-on understanding. Students will use 100 grids, counters, and base 10 blocks to physically build and shade the percents. This will help them see that the percent literally means out of 100. We will also start introducing bar models, but only in a simple way, just enough to connect the concrete and visual and the repetition. And it is the goal for this is to comfort and be familiar with the assignment, not just with the speed. On day two is where we will shift from hands-on to drawings. The students will draw bar models based on word problems and labels, the whole, percent, and the part. We will talk through how the bar model shows the relationship between these pieces. Once they understand the visual, we'll connect it to the equation. This is the day where the students realize how the equation matches the picture. On day three, it is all about applying on what they have learned. The students will work on the real world percent problems such as discount, tax, tips, and surveys, and comparisons. They'll also solve in groups so they can explain their thinking and compare strategies. We want them to be able to move between concrete, representational, and abstract methods, depending on what makes sense to them. By the end of day three, the students should feel more confident in solving percent problems independently. The CRA model is a progression that helps students build real understanding before we ever ask them to solve equations. We will start with a concrete stage. The students will use physical objects like the 100 grids, counters, and base 10 blocks. This lets them see and touch what a percent actually represents. Once they're comfortable with that, we'll move to the representational stage. Here they will draw models or tape diagrams to show the same percent relationship visually. The bar models becomes a bridge. It connects the hands-on work to the math symbols that they'll use later. Finally, we will move to the abstract stage. This is where the students will use equations like part equals percent times whole, but we only get here after they built a conceptual foundation. The goal for the students is to understand why the equation works, not just memorize it.
Visual learning, how students learn visually. The bar is divided into equal parts, the percent is labeled clearly, and the unknown is shown with a question mark. We have a few examples right here with visual flow. So you have 100% and then it's split known percent, unknown percent. And then we also show how students learn visually. So it shows right here the BA 100% split known percent unknown. And then this shows how students use visuals to understand percent. They break a whole into parts, label what they know, and use a question mark for what's missing. This helps see the process before solving it. Then we have an example. And then on this slide, I'm focusing on visual learning and how it helps students understand percent problems. First, students break a whole into equal parts, usually starting with the 100%. This helps them see the full picture before solving anything. Next, they clearly label the percent they already know, and if something is missing, they use a question mark. This makes it easier to identify what they are solving for. The visual flow is important. Students go from 100%, split it into parts, find the known percent, and then use that to figure out the unknown part. This process helps students see the math instead of just memorizing steps. It builds understanding and confidence before they even start calculating. For example, if we have 40% of 100 plus an unknown, students can visualize the 100, break it into parts, find 40, and then determine what's missing. And then work example 30% of 50 is what? So we have a few examples. And then this is an example using a bar model. We start with the whole 50 and split it into 10 equal parts so each part is 5. Then we take 30%, which is 3 parts, and multiply it to get 15. So 30% of 50 is 15. Finally, we multiply 3 times 5 to get 15. This shows how the bar model helps break the problem into simple steps and make it easier to understand where the answer comes from. For this example, we know how bar models help students solve percent problems visually and step by step. We begin with the whole amount, which is 50, and represent it as 100%. Then we divide the bar into 10 equal sections because each section represents 10%. Since 50 divided by 10 equals 5, each part is worth 5. Next, to find 30%, students identify 3 sections, since 30% equals 3 groups of 10. Finally, multiplying 3 by 5 gives us 15, so 30% of 50 is 15. This strategy helps students clearly see how percentages relate to the whole, making abstract concepts more concrete and easier to understand. Student talk and collaboration. Student talk and collaboration is essential because it helps students actively process math concepts instead of passively receiving information. And then I looked up like some strategies online for why it's important for students to collaborate and talk. And I didn't put the citations over here, but this is from online. And it basically just explained that 75% more of students were able to process math quicker when they collaborated with either a teacher or multiple students rather than doing it on their own. So student talk and collaborations is essential for math instructions because they help students actively engage with concepts instead of simply following procedures. In percent problems using bar models, student talk allows learners to explain how they interpret the whole, break apart percentages, and justify their strategies. Wait, sorry, I lost my place. This process encourages deeper understanding because students are not only solving problems but also discussing why their methods work. Student prompts such as what does 100% represent and why does our answer make sense push students to think critically and communicate clearly. Overall, student collaboration builds confidence, it strengthens mathematical vocabulary, and supports meaningful problem solving by focusing on reasoning and conceptual understanding rather than just finding the answer.
So mathematical practices, there's 3 main ones. The first one is to make sense of the problem. So students are basically working to understand what the problem is asking them before even solving it. Students will use the bar model to break down percent problems and understand the relationship between the parts as a whole before even solving. So they'll identify the 100 whole percent. They'll figure out what the percent represents. They'll determine what is missing and then they'll use the bar model to identify it visually. The second practice is construct an argument. So students explain and justify their thinking, not just give answers. Students use a bar model to explain their reasoning and justify why their solution works. Um, Students explain why they divided the bar a certain way. Sometimes they may go into a deeper version and do it the longer way as dividing the 100 when there's a simpler way. They'll justify how each section represents the percent. They use a bar model to provide their answers so that way it makes sense. And they can compare their models with others to discuss differences to see how others may have done the problem. The last one's they'll model with mathematics. So students represent real world situations using math tools. Basically, they just want to connect the math to the real world experiences, such as when they go into a store and they find a percent off on an item or there's an increase on an item. The bar model represents the whole and its part, and they just use a model to solve and check their answers. There's three common misconceptions. The first one being the confusing part versus the whole. So students don't always know which part is the total 100% and what's just a piece of the bottom. So to fix that, we make sure the whole bar is clearly labeled as 100% so students can see what the total is and what part we're finding. Another misconception is using the wrong operation. Students guess whether multiplying or dividing because they don't understand the problem structure. Basically, for the finding the percentage, they'll divide it when in reality they need to multiply it to find out what they're needing. So having the students draw a bar model first so they can see the relationships, then the operations make more sense. The last misconception is that thinking percent over 100 isn't impossible. Students think that percent stops at 100 when in reality it could go higher and more into depth really. So we need to show the part going past 100 so they can see the amounts can be more than a whole. And then a strategy is to always return to the visual model even if you already did your whole problem just to piece in everything and make sure that you did it right. And then always allow students to go back to the bar model because it helps them understand, solve, and explain percent problems. Growth mindset is very critical in the bar model. So, teaching language, your model shows your thinking process, even if your answer isn't correct. Mistakes help us notice patterns in understanding percentages better. They explain how you divide the whole in your model. Different strategies can lead to the same answer, and we're going to focus on understanding the relationship between the parts and the whole. So what students need to do is create and revise models to represent percent problems. Label the whole parts and percentages clearly. As you can see over here, there's an example of a question where Maria saves $120 for a class trip. She spent 40 of her money on new clothes for the trip. How much did Maria spend? You can see I divided them. I did a whole part, which is 100, and that's the 120 that she saved, where we needed to find the 40%. So dividing the 100% equally, I did 20%, which is the 5 divided by the 120, which is 24 each 20%. And then the 20%, there's 40% we need, so 24 and 24, we add it and it's 48. Um, they'll compare different bar models, strategies with classmates. They'll explain reasoning step by step using visuals and identify errors and adjust models based on feedback. A key idea for this is to focus on process but not speed. Bar models help students visualize percentages as parts of a whole, and they help students build conceptual understanding instead of memorizing formulas. Visual models make it easier to connect fractions, decimal, and percentages, and also revising a model straightens problem solving and critical thinking skills.
For this lesson closure, bar model reflection, students reflect on how the bar model supported their understanding of percent problems when they would choose to use the strategy. For possible student thinking, the bar model helped me see the whole as 100% and organize the parts. It made it easier to break apart percent problems visually. I would use it when I'm unsure how to start or when the problem is confusing. It helped me check if my answers make sense. And those are just some possible student thinking. But as for key mathematical connection, part equals percent times whole. The bar model represents the relationship visually. The equation represents the same relationship symbolically. Students move from visual reasoning to algebraic thinking, but only after they understand the bar model reflection. And that's our bar model concept.
Thank you.
Thanks.